Hey everyone, welcome back. We're going to do a quick lecture on both expressing and interpreting emotion. Normally in class, this is a 2-day lecture, and we're going to go ahead and try to bring this down into less than 10 minutes and just touch on some of the highlights. So, expressing emotions. We have what are considered six universal emotions, and they're universal in a couple of different ways. One, they are universal in the way that we actually express them with our face. We have over 40 different muscles in our face that allows us to portray these very specific emotions, as you can kind of see below here. These are emotions like happiness, sadness, shock, fear, surprise. And then they are also universal in the way that we can recognize when other people have these emotions. And this is really important for the nonverbal communication, where even if you don't speak the same language as someone, if you see someone who is angry or if you see someone who is afraid, it is important that we can pick up and we can see these emotions on other people. Now, in relation to emotion in the brain, there are lots of different parts of our brain that deal with emotion, but I'm going to just hit on some of the real big ones that we tend to see show up on the test over and over again. The first one is the amygdala. And I like to tell students that if you see a question about emotions and brain structure and you don't have any idea, and amygdala is an option, pick it. It's probably your best bet. There's lots of ties between our amygdala and experiencing lots of strong emotions. We know, for example, that if you stimulate the amygdala of a lab rat, it'll become very aggressive. We know that if you remove the amygdala of a rat, it will no longer show fear and things like that. Your cingulate cortex is this part of your brain that really rests between your subcortical structures and the cortex that's above it. It's kind of the bridge between these two, which is important because subcortical structures, that's kind of the central zone for a lot of memories and emotions. And then your cortex helps with a lot of critical thinking. And so your cingulate cortex bridges the gap between these two brain structures. So your cingulate cortex helps you interpret different types of pain, for example. Your cingulate cortex helps you better interpret stimuli and an emotional response. People who have a really overactive cingulate cortex may be more likely to experience anxiety and things like that. And then your basal ganglia, this is highly involved with the emotion of disgust, which kind of makes sense. Basal ganglia helps with like small movements, and disgust is very much a reflex emotion of you trying to literally put distance between you and some particular stimuli that may be harmful or dangerous. Now, when it comes to theories of emotion, in other words, how does some particular stimuli result in an emotion? We have these three different theories that are really popular. Hopefully, you can see this graphic. If you can't, you can just Google theories of emotion, and there's tons of graphics. It's in your textbooks. It should be in your notes. I chose this one because that guy's face is just absolutely hilarious to me. But let's go through these three different emotions. The first one is the James Longue emotion theory of emotion. And you may recall that with James Longue, the way that it works is there's some particular stimuli. In this case, it looks like a big old brown bear, grizzly bear, and that stimulus will lead to a physiological response, increased heart rate. You're trembling, you're sweating, things like that. And then every physiological response is paired up with some particular emotion. And so, in this case, that physiological response is paired with the emotion of fear. And every emotion we have has a different physiological response according to the James Longue theory. The problem with this theory is through research we have found that different emotions actually have incredibly similar physiological response. So what your body does when it is afraid is really similar to what your body does when it's angry. And it's really similar to what your body does when you're falling in love. And so there's some holes in this James Longue theory. So our next theory would be the Cannon-Bard theory. And with Cannon-Bard, you have the same stimulus, only instead of leading strictly to a physiological response, the stimulus is going to lead to both a physiological response, like pounding heart and sweating and things like that, but it will also lead to the emotion, the cognitive emotion. And these two things happen what Cannon-Bard calls simultaneously and separately. They don't impact one another. They are both happening at the same time. But there's a problem with this theory too, and the problem with this theory is we know that if we manipulate one, the other can change. So they are somehow connected. For example, if you take anti-anxiety medications, right, that physiologically will change what's happening in your body, will calm your body down, your emotions do in fact change. So there is a connection between the physiological response and the cognitive emotion, despite Cannon-Bard saying that they're separate. Which leads us to what is perhaps the most commonly accepted theory, which is what we call the Schachter-Singer two-factor theory. And with the Schachter-Singer two-factor theory, what happens is there's a stimulus. We've got this scary-looking bear, which leads to a physiological response. Your heart's pounding, you're starting to sweat, your pupils are dilating. And then you give it a cognitive label, or what we sometimes call a cognitive appraisal. In other words, you think about that physiological response, and this can happen in a fraction of a second. And depending on both the physiological response and the cognitive label, that leads to an emotion. In other words, your heart's beating really, really fast. Well, is it beating really fast because you're afraid, or because you're excited, or because you're falling in love with this bear, right? It requires two factors. It's the two-factor theory, both the physiological response and the cognitive label or cognitive appraisal that goes along with it. And then our last slide, just some other like big terms that we talk about when we talk about emotion. The spillover effect is this idea that if we change a cognitive appraisal, then it's possible to change an experienced emotion. And so I like to give the example of stepping off of a roller coaster. When you're on the roller coaster and your heart's beating really fast and your pupils are dilated and you're sweating, you're likely afraid, right? Or maybe you're excited. Well, when you step off the roller coaster, it's not like your body completely goes back to normal. You still have this state of physiological arousal, but now you can change your appraisal of that physiological state to some other particular emotion. And so that emotion like spills over, if you will, right? There's a guy named Richard Lazarus, and Lazarus talks a lot about fear and how we experience fear. And some fear happens really, really quickly. It takes what we call a low road, and it essentially goes from your thalamus in the brain directly to the amygdala. And so things like thunder, that's really sudden. You become frightened and scared. That's a low road fear. Other fears, however, you have to think about. You have to think, is this a scary situation? Like, should I fear what it is that I'm witnessing in this moment? And that's a high road. That has to go through the cortex. And so that information travels, and we can see this through brain scans, from the thalamus to the cortex and then to the amygdala of, it turns out, you know what, I think this is kind of a freaky situation right now. So that's a high road fear. Looking at happiness, I have some different terms there that impact happiness. Adaptation level is simply this idea that we don't really experience strong, polarized emotions for long periods of time. Something can happen today that makes us really, really happy, but that emotion fades over time, right? When the Chiefs won the Super Bowl, I was over the moon excited, really, really happy. And it still gets me excited to think about today, even though it's been 3 months, but it's not the same level of happiness as it was right when that happened, right? Because we tend to go back to the center. And then relative deprivation is we constantly like to compare ourselves to our colleagues, our peers, our friends, our siblings. And so sometimes that brings us down. It's kind of the whole grass is always greener syndrome, right? Where maybe I was perfectly happy with my car until I saw the car that my colleague is driving. Maybe I was perfectly happy with my paycheck until I heard what this other person was earning. And so relative deprivation, comparing ourselves to others, sometimes brings us down. Finally, there, emotional intelligence. That's sometimes taught during the actual intelligence unit. I like to save it for when we talk about emotions. Emotional intelligence is this idea. It's our ability to pick up when people are feeling a certain way, be able to pick up on how certain stimuli can change other people's emotions, being able to identify our own emotions. Like my children, for example, sometimes struggle to differentiate when they're frustrated and when they're angry, right? And those are two different emotions, and they sometimes mix those two things up. And so emotional intelligence is your ability to identify emotions and better understand emotions. And if someone is able to to really put themselves in someone else's shoes and really experience the emotion of other people. This is what we call sympathy, or sorry, this is what we call empathy, which is different than sympathy, which I was going to say. Remember, sympathy is just feeling sorry for someone else's experience. Like, that must really stink. I feel really bad for you. But empathy is really being able to experience that and experience what that may be like, the emotions of another person. So, pretty quick. I hope that helped. If you have any questions at all, don't hesitate to reach out. Good luck.